Welcome to the amphitheater here at the Corning Museum of Glass. We're going to be demonstrating some different ways to make window glass from old times. This is Rochelle. He is our gaffer. He's going to be making these pieces for you, and he's going to be assisted by Alex Young. My name's Jeff Mack, and Linnea is here, and she's going to talk a little bit about the different methods a little more specifically.
Yeah, hi everybody. I'm Linnea Seidling. I am assistant curator here at the Corning Museum of Glass. And today my role will just be to introduce the three techniques that our team will be demonstrating with an 18th century corresponding print. So all the depictions are plates from a source with which I'm sure many of you are already very familiar, the encyclopedia or a systematic dictionary of the sciences, arts, and crafts, more commonly referred to as simply Encyclopédie or the Encyclopedia. It was edited by Denis Diderot and Jean d'Alembert and published in Paris with the first of the 28 volumes released in 1751. We saw most of these plates earlier today during Kit's talk, and I will flash them up when we do each of the methods. Okay, off to you guys.
All right. So Chris is working on making a crown or a rondelle, which is how you make a crown, a piece of crown glass. A crown glass is indicated. You'll see a pontil scar in the center, and it's made out of a bubble of glass. Linnea, were you going to say something about this?
Yeah, let's pull up the print. I should have done that.
Pull up the print. Okay, and there we go.
As Jeff mentioned, if we can pull up first slide, thank you. The first method that we're looking at today is the crown method, where centrifugal force is used to create a flat circular sheet of glass known as a crown, and from which square or rectangular panes are cut. If you could go to the next slide, please. It kind of give us a bit of a detail into that bigger plate that we saw. So here on the right side of the plate that we were seeing, from the encyclopedia, we can see the glass workers at pretty much every step of this process, from gathering the glass to creating the circular plate. So let's watch it happen.
So that was a really big rondelle in that picture. So what you're going to see Chris working on is almost like a scale model of that. That one looked like, you know, compared to the size of the person, looked like it was a couple feet in diameter. Chris's will probably be about 15 inches in diameter, I would think, something like that. So he has gathered up the glass out of our furnace. We have a couple different types of furnaces here. And today, our furnaces are fueled with natural gas. We also have some furnaces that are powered with electricity and that uses elements to heat the chamber. Now, when crown glass was invented, it was around 250 to 480 CE. So a long time ago, very shortly after the invention of glass blowing. So the furnaces that they were using to make original crown glass would have been fueled with wood. So that's the main difference to what you're seeing here today. And also we have stainless steel pipes and tools. So other than that, the actions that you're seeing Chris doing here are very similar to what you would have seen around 2,000 years ago. Now, because we're wearing masks during the pandemic, you might not be able to see it on the video, but if you back out a little, you can see Chris has a hose attached to the end of his blowpipe. So the blowpipe is that rod that he has. It's actually hollow inside. It's a hollow steel tube. And we're using compressed air to inflate that bubble while he tools it. So he's got a little foot pedal there. He blows it up using compressed air instead of the traditional method, which would have just been drawing the pipe up to your mouth, blowing into it, and inflating it like a balloon. So that's how it's been actually done since around 50 BC. But we're making do here with compressed air. It seems to be working very nicely. And the real trick here with the crown method is taking that blown bubble of glass, which is very easy to make, and then turning it into a flattened disc. And how do we do that? So we take this bubble. The next step that Chris is going to perform here with the assistance of Alex is they're going to attach another rod to the center of the bubble on the opposite side of the hole that he was blowing through to inflate it. So that'll leave a nice opening. And then to flatten that out, he's going to have to work that hole open all the way up until it expands out into a flat disc. And that is by using different tools to open it and expanding it in stages, and then finally using rotational force to flare it out into a flat disc. And then once that's flat and rigid, after it cools down just a minute or so, it can be placed into an oven to cool down slowly so it's in one piece. And then, as Linnea had said, then the disc is cut into multiple squares. So that's why you would have seen, older windows usually have much smaller panes because they're either cut out of a rondelle like this or a cylinder. So rondelles, because they're round, the size of a square plate then you can pull out of it is pretty limited. Now, Chris has already started the process of flattening the bubble while it's still on the blowpipe. So he's flattened it out. We have sort of a lobe-shaped bubble or a bun-shaped bubble rather than a sphere. And that's going to open up flatter a lot easier than if it was just a sphere. And now Alex has gathered a little glass on the very end of a solid steel rod. This is called a punty or a pontil. This will be attached to the center of the bubble. And they don't want it to fuse on there. They want it to be a weak connection. Actually, they are going to fuse it on there. They're going to leave a little bit of that glass on the bottom of this. And that makes that little bullseye. So after this gets broken off of the punty, when the piece is finally flattened all the way, the bullseye is left on there. And that's where you get the little crown in the crown glass. Now, Chris is using compressed air also to speed up the process. We have a very limited time to perform these demonstrations, so that compressed air can help cool the glass quickly when we need to do that. So back to the furnace they go. You can see that small hole, maybe an inch in diameter, where they broke it free from the blowpipe. And Chris is going to work on heating this up and expanding that hole again until he can use rotational force to finish off the form. Now, let's see, this type of glass was invented in Roman times, but it wasn't really brought to England until the second quarter of the 14th century. So that's when they started making crown glass in England. And the English were some of the first to use, well, they were the first to use coal in the glass making industry. So that their furnaces would have been quite a bit different than the ones we use, and quite a bit different than furnaces used in other parts of Europe, which were burning wood. And I believe coal was used in the 1600s in England for firing glass furnaces. It was actually one of the reasons the New World looked so appealing. The trees, there was so much wood. And you can imagine the English were so reliant on their own wood for building ships and such. So I think it was King James said that they couldn't use wood anymore. They had to find new sources, and coal was one of the top sources that began to be used by the glassmakers. All right, so you can see how Chris is very quickly starting to expand this form. In just a couple minutes, that's going to be a flat sheet of glass, and it's going to happen in a very sort of explosive move. He's going to actually spin that out, and he'll increase that speed. You can see he's already starting that now. At the other bench here in the shop, we have Alex. She's starting up the process just as Chris was for this bubble. So she has a core bubble, and then she'll start to layer on another layer of glass over top of that. And she's just building up a core that Chris can make the next type of flat glass on, which will be the cylinder method. So we're just doing these really quickly, one after the other, so you can get the general idea of the technique. So here's the rotational force. He's rotating. You can already see the bubble starting to distort, and here it goes. Flat as a pancake. Now, even a disc that large, 15 inches or so, you can probably get about 8 little panes of glass out of there, and a nice crown in the center, a nice bullseye. So once that's set up, it'll just take about a minute or so while Chris finishes tooling it. He's going to drip a little water on that connection where the punny is attached. Sharp tap to his iron will break it free, and there we have the finished plate. And into the oven this goes. This piece is still about 1,000 degrees, and everything that we make is about that temperature when we're finished with it. If we let it sit out in the open air, it would cool so rapidly it would break from thermal shock. So everything has to be placed into an annealing oven. So the cooling slowly is called annealing. It's a process that is necessary for this type of glass. So immediately, Chris is starting into the cylinder method. Linnea, did you want to talk about some of the prints?
Yeah, real fast while Chris is getting started. So the second method we're looking at, as Jeff said, is the cylinder method. If you pull up, great, you've already got the slide up. So as Kit mentioned earlier today in his talk, plate glass was made in this method. The plate glass that was made in this method was the least expensive. This illustration from the encyclopedia shows the beginning of the process where the glass is gathered, marbled on a metal or stone slab, inflated and shaped into an elongated bubble, which we can see on the right side. Next slide, please. So this second plate shows how the long bubble is turned into a true cylinder that is then cut lengthwise and opened to create a flat rectangular sheet of glass. And so we'll watch that happen.
All right, very cool pictures. Again, this is sort of a miniaturized process of the cylinder method. And you know, small manufacturers of customized stained glass would make cylinders this large, but typically for industry and window making, the cylinders would have been much, much larger, up to 8 feet long. And it depends on the manufacturer, but they would try and get as much material as possible. And the idea with the cylinder is that instead of making a round bubble and spinning it into a disc to make the flat glass, what we do is make a large cylinder, and then the cylinder is opened at both ends, cut along one edge, and then flattened out in a kiln. So by making a much longer, larger cylinder, you can get a very, very large piece of glass, which is really the end goal, is to get the largest piece of sheet glass that you can. And that's really one of the motivators for the development of technology in the making of sheet glass, is to get the largest sheet possible. And nowadays you have buildings with panes of glass that are tremendously large. I mean, just look at the galleries here, the North, the art and design galleries. You know, there's enormous sheets of glass there. And that's done with the float glass method, which is not covered today. It comes much later. And so cylinder method of making glass came a little bit late to England. It didn't get there until the 17th century. They were already doing it in France at the time, but the English were a little bit later to adopt this method. So again, to expedite the process, Chris is using some modern tools. He's using a hot glass torch here just so he can burst open the end of the cylinder in a quicker fashion. Otherwise, it would take a couple minutes to get a nice hole in there and open the end of the cylinder. And then what they're going to do Again, to accommodate the scale and to accommodate our shop, they're going to put what's called a face puntee on here. So in a similar fashion to the rondelle, we're going to attach another iron, break it off of Chris's pipe, and then open up the opposite end. So that process is coming up here pretty soon. Alex is preparing that face puntee. And oddly enough, the face puntee is like a small rondelle. So it's essentially to make the face puntee, we had to go through the process of making some crown glass. So Chris can trim the glass so he gets a nice even edge. Now, when the cylinder glass was traditionally made, it would have just been made off of one blowpipe. It wouldn't have been transferred from one to the other. And then the ends would have been scored and cracked off. And then they would have been loaded into large ovens where it could be flattened out. Now, we're just so we can show you the process, we're going to actually flatten it in this very same kiln that we're making it in. So we don't have the exact specialized tools that a cylinder glass factory would have to make these cylinders. So we're kind of improvising a little bit so we can use our own systems here to show you the process. All right, so I'm going to help out a little here, just help Chris flatten out the edge. So the tool Chris has in his hands right there are jacks. So we're sort of adapting vessel making techniques to making cylinders. But this gives anybody who's interested in the technique the idea of how this method differs from the crown method. Then the third method that we will get into here in a little bit, in a few minutes, is the cast method, casting glass, where there's no blowing involved at all. It's very quick, and you could get very large sheets very quickly. All right, so Alex is coming over to help out. She has a face puntee there. Again, it's just like almost like the crown that Chris made a little bit ago, a little smaller. They attach that to the open end of the cylinder. And because the temperatures were so different there, when they go to break that off, that flat disc will easily break off the edge of the cylinder. And again, this is sort of that part of it is an augmentation of the traditional cylinder method, so we can demonstrate it with our own tools. So we're not going to do these right now. Okay. All right, so while Chris is taking the time to heat that and open it up, he wants that cylinder to be straight walled, and it's still closed at the end that the pipe was attached to. He's going to heat that up, open it straight. While he's doing that, Alex and I are going to use the cast method to pour out some glass on the steel table here, and then use basically a large steel rolling pin to flatten it out. And Linnea, do you want to talk about the casting method a little bit?
Sure. So the third and final method we'll be seeing today produce the largest sheets of glass, casting. It was the most flawless and the most expensive, as Kit talked about earlier today. As we can see in the illustration, a pot of molten glass is poured onto a metal tabletop with shallow walls. The glass workers then evened out the glass with what looks like a giant copper rolling pin. And I'm most excited to see this one today.
All right, so you can see Alex's hand there. She's at the furnace, and you'll see how direct this method is. I'm just gonna dip a steel ladle into the furnace. Alex is gonna trim off the stuff there. Then we're gonna pour this onto the steel table. There we go. And here comes the rolling pin. I imagine if you do this every day, you get a lot better at that pouring part. But you can see Alex can just basically squish that glass out into a sheet of glass. Immediately we have something that could be used for a window. So that's pretty quick. And that's why we were able to demonstrate it very quickly while Chris is just taking the heat for the cylinder there. And you can see how quickly the heat is dissipating from that just by the color changing. So that steel pulls a lot of heat out of that glass. And I imagine when tables like this were cast out of iron, they'd probably take even more heat out of the glass. So the same with this. This one we won't put into the oven. It'll take a little too much space up in our oven. But let's slide it onto this. So I'm going to take that off. It's still probably about 1,000 degrees at this point. And normally this would be loaded into a leer, which is similar to our annealing ovens. It's an oven meant for cooling the glass. However, you'd have a gradient of heat that the glass would move through to cool it down. So a leer is like an oven that's a long tunnel with different zones of heat. And usually the heat source is at the hot end, of course, where the furnace is. And then the further you get away from the furnace with that tunnel, the cooler that tunnel will become. All right, so Chris is now ready to break that cylinder off of the pipe. And then we're going to put it onto a kiln shelf that it can be flattened on. So he's using a trick here to cool down the very back edge of that plate. We're using thermal shock to release that cylinder. So the difference in temperature from the back side of that plate to the front side of it is going to be what will help this to pop off very easily. There we go. Nice job. And then this is our simulated flattening kiln. So we're going to use our reheater or our glory hole as a flattening kiln here, but it gives us a great camera view. We have a nice fused silica lens in the back that we have a camera behind, so you can actually see what's going on in that furnace, which makes this type of demonstration so much better. So you can see what's happening in the heat. All right, so Chris scored the glass. He tapped it and it broke along one side. So he has a vertical crack going up that cylinder on one side that he's intentionally put there. So we like to say in our demonstrations that we're not only expert glass makers, we're expert glass breakers. And Chris has done this many times. When we were demonstrating the artistic glass of Louis Tiffany, Chris really perfected the technique for opening glass cylinders with different patterns and colors. So he's used to this method. So they're just softening the cylinder. Chris is letting Alex know how long it needs to be in there. Now, if this was traditional cylinder making, this sheet would be much larger. You wouldn't have it coming in and out of the kiln. They would be using long sticks to flatten the glass out, long sticks. Literally. Wood is a great shaping tool for glass. So you can see Chris wants everything evenly heated. And again, this furnace isn't ideally suited for this type of work. So it has an uneven heat, which is great for glass blowing when one side's hot and one side's not. But for making cylinders like this, you really want an even heat. So he's flipping the kiln shelf around to even out that temperature. And once everything gets to about 1800 degrees or 1900 degrees, it's going to sag flat and it's going to flatten out against that kiln shelf. Here he's using a cork paddle to flatten that out. And that's it. Nice piece of cylinder glass. All right. Excellent.
Well, thanks everybody. Thanks to Jeff and Chris and Alex. You guys did a fantastic job. And we're going to go back to our third and final, I believe final, panel discussion today for our 59th annual seminar on glass. Thanks everybody again.